Good evening, friends. Welcome to Multiverse Exams YouTube channel. Here we will be focusing on Gate ESE, SSC JE, all AE JE, PSU exams, and engineering going students for semester exams. Also, in the previous class, we discussed on what is the introduction of thermodynamics and system surrounding, what is boundary, what is universe, etc. Here, what do we mean by universe? The summation of system and surrounding. So now moving further, what is the difference between a surrounding and environment? Okay. Suppose I am taking a stove and I am lighting it up. What happens is, when I am lighting it up, the immediate part of the system only the temperature changes. Here, what is the system? The system is candle or stove, whatever it may be. So, suppose in a room now you are lighting the stove, the total room doesn't get affected. The immediate part of the stove only get affected and the temperature changes. Means the properties of this immediate part only get changes. This part. Okay. So now I can define it as the part of surrounding where the intensive properties changes during energy interactions is known as immediate surrounding. In surrounding, and the remaining part doesn't changes. The intensive properties doesn't changes. Where the intensive properties doesn't changes is known as environment. As I told you before, this is the immediate surrounding, and this remaining part this remaining part is the environment. Okay. This is the environment, and this, so now I can tell the combination of immediate surrounding and environment is known as surrounding. Can I tell it? Okay. For the definition of the environment will be where as the intensive properties doesn't change during energy interaction is known as environment. Okay, as I told you, the summation of immediate surrounding and universe is immediate surrounding and environment is known as surrounding. So can I write it as surrounding is the summation of immediate surrounding plus environment. Now moving further, types of system. There are three types of system. One is closed system. Second one is isolated system. Third one is open system. Now we will discuss on closed system. Here what do you mean by closed system is there is no mass transfer or interaction but there is energy interaction. Here energy interaction means heat interaction or and work interaction. Okay, now moving forward, I am taking a container which is filled with air. And here the air is the system. I am considering air as a system. And this is the internal boundary of the system. Suppose the mass of the air is m1 and the temperature of the air is T1. Now I am supplying heat of 200 kilojoules of heat to this system. What happens further is the temperature increases but the mass remains same. Why? Because the boundaries are rigid. Air is the system and the temperature changes to T2 and the boundary of this is the boundary of the system. Okay, this is the rigid container. When I am supplying heat to the system, with 200 kilojoules of heat, the temperature changes but the mass remains same and there is no any work done for this system. So the displacement work of the system is 0. Okay, so I can conclude is closed system having have rigid boundary. Now moving further, I am taking a piston cylinder arrangement which is filled with air. Here the system is air. And this is the boundary of the system. Suppose the mass of the air is m1 and the temperature of the air is T1. Now I am supplying heat to this air with a 200 kilojoules of heat. Okay, what happens further is the temperature of the air increases and the piston rises. Okay. Sorry. This is the boundary of the system. What happens is the piston rises when I am supplying heat. It means there is some work done for this system. Okay, means the boundaries remain same at the bottom and below the piston, but there is a change at the curved surface of the boundary. Okay, for the here for the closed system the boundary is flexible and there is some work done. Now I can write here is closed system having flexible boundary. Okay, here in these four diagrams, what we have observed is there is um energy interaction is taking place, but there is no any mass interaction. Here I can conclude is that we the mass uh, sometimes we call closed system has a control mass also. Okay, so now for closed system having all rigid or fixed boundary, the displacement work is 0. As I told you before, sometimes we use closed system has control mass. Okay, if you have any idea about IC engines, in IC engines it takes four processes to complete a cycle. One is suction, second one is compression, third one is expansion, and the final process is exhaust. Okay, in compression and expansion process, the fuel air mixture or the air which comes inside the cylinder remains the same. So now I can tell is that these two processes behave as a closed system. Okay, and the third point is the compression and expansion strokes of a IC engine represents a closed system. This is all about the closed system. Now moving further, isolated system. What happens in isolated system is there is no mass transfer or interaction or energy interaction. Means there is no mass transfer interaction and no energy interaction. Nothing takes place. So now I'm taking a piston cylinder arrangement or a rigid body. First of all, this rigid body is containing air, and I am considering air as a system. Suppose the mass of the air is m1 and the temperature of the air is T1, and what I am doing is I am insulating this rigid container. Okay, now I am supplying heat of 200 kilojoules to this container. When the container is rigid and it is well insulated, mainly the container is well insulated, there is no any energy interaction. When there is no any energy interaction, there is no displacement work. Okay, so I can tell is that this is an isolated system. Now moving further, I am taking a piston cylinder arrangement. Which is well insulated. Here the air is the system which is having a mass M1, and the temperature of the air is T1. Now I am supplying heat of 200 kilojoules. There is no energy interaction, but the piston have the power to displace. So the piston has the tendency to move up or down. So there will be a work displacement, means no there is work interaction. Okay, some work done will be there. So the system is an not an isolated system. Now moving further, isolated system and insulated system. Guys, please don't confuse in isolated and insulated system. Now I am taking a piston cylinder arrangement. There is no, sorry guys, as I told before, there is no heat interaction. So here we can write as 0. Okay. Here air is the system, there is a mass and same has temperature. We call it as a insulated system. Okay, now I am taking same to be an isolated system. What we have to do is, there is here we have observed before is there is some work done. Here work done is not 0. Okay, to the work done to be 0, what we have to do is we have to apply stoppers. Okay, here the work done will be when it will be 0 when we apply stoppers, and the stopper is also insulated. Okay, this is an isolated system. And this is insulated system. Okay, and you have observed uh, there in the market we see a bottle. When we pour milk, any liquid item in that bottle, with some temperature, the temperature doesn't change. There will be no energy interaction and there will be no any work done. The bottle is the thermo flask as we see in our daily lives. Okay, here thermo flask for an isolated system, we can use thermo flask as an example. Or we can say an insulated bottle. Any other example? As we studied before, that system plus surrounding is the universe. This is the system and this is the surrounding. And this is the universe. Here universe also act as an isolated system. So another example will be universe is an isolated system. Okay, so in the definition form we can write it as for insulated system, heat interaction is 0 but work interaction can take place. In the previous class, guys, we have studied that thermodynamics deals with energy interactions and its effects on the properties of the system. Here the energy interactions means heat interaction and work interaction. In isolated system we have seen that there is no mass interaction and energy interaction. Energy interaction means heat interaction and work interaction. So we will not study further about the isolated system because there is no mass interaction. Energy interaction means the heat interaction and the work interaction. Okay, since thermodynamics deals with energy, interaction, and in isolated system there is no energy interaction. So we don't study it in detail. Sorry, guys. Okay, let's conclude this session today. We will move forward tomorrow. Okay, my health is not fine. Guys, please do subscribe, like, share with your friends who are preparing for Gate ESE, SSC JE, all AE JE exams, and some engineering students who are going for semester exams. I am trying to bring more best content for you students. Please cooperate with me. I will be further taking questions also on of Gate previous year questions and SSC JE questions, ESC questions, all PhD questions also. Okay.